Hello and welcome to Maths with Jacob. This lesson will focus on Tricky Maths Part 56. When hexagonal tables are joined in the above manner, each exposed edge represents a place where a person can sit. How many seats would be available if 8 hexagonal tables were joined together? What an interesting problem this is. So here we see a single hexagon. Here we've got 2 hexagons joined together using that edge. And here we add an extra hexagon. So if we keep doing that all the way down and have 8 hexagons altogether, how many seats would there be? Now if you want to solve this, you can pause the video now and see how you go. I'm going to now move on to the solution. Now here's your chance to pause the video. So for the single hexagon, you can see that there are 1, 2, 3, 4, 5, 6. So you can put 6 chairs around there, so you've got 6 seats. When you add the extra hexagon, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 seats. Add an extra one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have 14 seats. So we can see the number of seats for each of the above arrangements. So we start off with 6, then 10, then 14. Now let's see if there's any pattern emerging here. So for 1 hexagon, you've got 6 seats. For 2 hexagons, there are 10 seats. For 3 hexagons, there are 14 seats. Now, do we notice any pattern between 1 and 2 and between 2 and 3? It seems that for each extra hexagon, we have 4 extra seats. So let's see what we can do here using that little rule. So let's move on now and write down 8 hexagons joined together, because that's what we're asked to do. So after 3 hexagons altogether, there are 14 seats. Add the extra hexagon, add an extra 4 seats. That takes it to 18. 5 hexagons is 22. 6 hexagons, 26. 7 is 30, and 8 is 34. So we just keep adding 4 seats each time. And we can see by applying that rule that we worked out here, for 8 hexagons, we have 34 seats. How's that for an interesting problem? I wonder how you went with it.